You must study third unit part A. Part B also, but I think as per they said 3 units. Any doubt in third unit topics? Last two days.
Ma'am, can you please clarify once more how many questions will be coming from module 3? Ma'am? Ma'am, are you here?
You are muted.
Yes, tell me.
Ma'am, can you please just once more clarify how many questions will be coming from module 3?
See, you talk loudly because it's heavily raining. I cannot able to hear properly. Raise the question properly.
How many questions will be coming from module 3?
Module 3, what is the syllabus portion for you?
And the number of questions, ma'am. The number of questions. How many questions will be coming?
Yes. Totally, you will be getting 10 questions. Each question carries 10 marks. The exam is for 50 marks. Okay.
No, ma'am, she is trying to say that how many questions there will be from module 3. As you just said that from part 1 you will be giving one question and part 2 the second question. But in total there must be 5 questions and two from 1 to module each.
Yes. Yeah, I understood. Totally 5 questions you are having. You will get 2 questions from each unit, and from third unit you study only the first half. You study only linked list, singly linked list, doubly linked list, circularly linked list. No need to study stack and cube. You got it?
Okay, ma'am. Thank you, ma'am.
So especially with respect to linked list, addition and deletion is they are the only operations. We are not concentrating on display and traversal. So addition and deletion means in singly linked list, doubly linked list. So what is linked list? What is the difference? What is the application? And addition and deletion, adding the elements in the beginning, at the end, or in between. The same way deleting in the beginning, at the end, or in between. So already we discussed first unit also. If you revise the first unit topics, so we have these are the topics we have. So here also As we discussed, we have first half and second half. So if you take the syllabus, first half, algorithm design, complexity and asymptotic notations. So the important topics will be algorithm design, complexity, asymptotic notations. And the second part, classification of data structure and abstract data type. Here, complex algorithm design means the steps we need to follow. Complexity means the time and space complexity. Asymptotic notations are big O, big omega, and big theta, best case, worst case, and average case. How we are deriving that. And if you take data structures, classification of data structure, primitive and non-primitive. Primitive are integer, character, float, and pointer. Non-primitive are linear and non-linear. Linear is array, stack, and queue. Non-linear is trees and graphs. And if you take abstract data type, the data along with the function, especially the user-defined data structures like stack and queue, they are having the attributes along with the operations. Stack, we are having the specialized operations like push and pop and the variable top and the size of the array stack. And if you take the queue, say here, even though in the third unit, part 2 stack and queue is not there, but here if you take the abstract data type, the example you need to represent as stack and queue and the linked list. During the classification also you will use primitive and non-primitive. That time you should be knowing what is stack and queue. Okay. Okay, the same way in sorting and searching, we are studying two different sorting and searching algorithms. We are under brute force algorithmic approach and divide and concur algorithmic approach. So in this approach, 3 sorting and 1 searching. In divide and concur approach, 2 sorting and 1 searching. Definitely 1 question from this portion and 1 question from this portion. Okay, any doubt? So you have to give importance to all the 4 topics: bubble sort, selection sort, insertion sort, linear sort. You should know the logic, pseudocode, and the program. Here also, merge, quick, and binary search. The screen is visible. Screen is visible. Okay, any doubt with respect to third unit? Am I audible or not?
Yes, ma'am.
Okay, if you quickly revise the unit 1. So you need to understand what is algorithm, what is the definition and how it is functioning, and what is the role of algorithms, and example for algorithm using any one algorithmic method, sorting algorithm or something. Then if you take what are the data structures, data structure is it's collection of data as well as algorithms. Data structures and algorithm is combination of data structures and algorithm. And if you take the data structures, they are user defined data structures like queue, stack, array, and string tree. And algorithms are that is classified or categorized as pattern searching algorithms, divided contour algorithms, searching algorithms, sorting algorithms. All the sorting algorithms will have some similarity. The similarity means they are all performing the sorting process. Searching algorithm, the logic is searching, but they use different steps and different methods. The same way, greedy algorithms, coloring algorithms, recursive algorithms, if any function calls within the same function, then it becomes recursive function, recursive algorithm. And the same way, linear means we will use iterative statements, iterative algorithms, backtracking algorithms. Any problem can be solved using algorithmic methods or based on the mathematical formula or based on the tabulation methods or graphical methods. It may the algorithm may be static algorithm or it may be dynamic memory allocation algorithm. And if you take the algorithm design, while designing, we have to follow some steps. The steps are defining the given problem statement, creating the algorithmic specification, analyzing the algorithm, whether it is useful to the given scenario or not, whether it will provide the efficient result, and implementing the algorithm using some language, and performing the testing and debugging process to overcome the drawbacks and errors, and optimizing the same algorithm so that it improves the optimizing or updating the statements and other things so that the efficiency increases. Getting an optimal solution, not the feasible solution. Optimal solution is important. The optimal solution will have the maximum efficiency in terms of less time and less space. So based on time and space complexity only, the efficiency of any algorithm is determined. So these are the steps we need to follow while designing the algorithm. So algorithm design, that this particular topic, you need to you should know these are the steps. We taken on bubble sort. In bubble sort, how these steps are implemented. And the corresponding bubble sort pseudocode we taken. And by taking an example, 5 numbers, how the iterations for loop and J loop, comparison, and swapping is performed using, because there are 5 numbers. So minimum we need 4 iterations. The same bubble sort, the C++ program. So the main program and the bubble sort function. Then the next topic is complexity. The complexity is measured in terms of time and space complexity. The complexity may be constant or algorithmic or linear, exponential, quadratic, and recursive. So time complexity is represented T of n, space complexity is represented S of n. Rate of growth means how it how stocks progress or what is the pickup. Time and space complexity for every operation, minimum searching, selection, everything for each and every executable statement, arithmetic assignment operation or comparison. For every iteration, we need order of 1 computational time. The same way, space also. So if the particular algorithm takes order of 1 means the particular algorithm comes under constant, it won't change. The computational time is order of, here we are using big O notation, order of n log n means it is logarithmic, the progress is logarithmic. So the same mathematical, order of n means it is linearly progressing. And the line linear algorithmic means n log n, quadratic means squares, exponential means 2 to the power. So from this graph you can understand constant, logarithmic, linear logarithmic, linear, quadratic, exponential 2 to the power. So it means with respect to the number of inputs with respect to the time. Say even if you give one input or if you give 100 input, if it is constant means the input sizes increases from 0 to n, but it needs only 1 second. But when it is logarithmic, a little bit extra time. When it is quadratic, it is progressing more fast. So when the input size increases, the time also increases. When it is exponential, even if you give 2-3 inputs, after 3 inputs, it's so it needs the maximum time for even for 2 inputs, 3 inputs. So like that, they are representing. So as per your syllabus, you are having that sorting methods like quick sort, merge sort, and selection sort, bubble sort, insertion sort. So those sorting methods, especially the asymptotic notations, they are representing in 3 forms: best, worst, and average. So best case, average case, and worst case, and the same way time complexity. So the complexity is differentiated as space and time. And asymptotic notation means mathematical representation. We have 3 types of notations. Big O notation, we are representing as capital O. This particular method takes the upper mode, so we are calling it as worst case. In big omega notation, it is taking the lower bound, so we are calling it as best case. And it is taking the theta notation exact bound, so it is taking the upper bound and the lower bound added and finding out the average. So here we have taken the insertion sort. For insertion sort, what is the best case, worst case, and average case, and how the constant, logarithmic, exponential, linear, and exponential is represented. Same, the bubble sort, insertion sort, selection sort, merge sort, and the quick sort. What is the best case, worst case, average case, time and space complexity. So if they are asking you to explain binary search, especially anyhow it is 10 marks or 10 marks complete, one question is asked. You have to say what is binary search and what is the time complexity and what is the logic used, what is the pseudocode, and some sample input output, and depending upon what type of question they are asking. Whether they are asking explain with the pseudocode or explain with the program, explain with algorithmic steps, whatever may be the algorithm or pseudocode or program, correspondingly you have to take some sample input of minimum 5 numbers or 6 numbers. You have to show how we are getting the answer. So the asymptotic notation is all about big O, big omega, and big theta with respect to best case, worst case, and average case. So then the second part of unit 1 is data structure and introduction, classification of data structure, and abstract data type. So these are the data structures. These are the algorithms we are using. And if you take the classification of data structure, built-in and user-defined, built-in are they are the part and parcel of the compiler, C compiler or C++ compiler. Without the data, because any program needs some character set as well as number system to perform any mathematical operation. So we need all integer, character, and float double, because we are doing the writing the program and project for doing some manipulations only. We need the character set, string, as well as the numbers to perform the task. So they are the basic things. So it will come under built-in. By using the basic character set, and we are creating the user-defined arrays, list, and files. If it is in linear, stack and queue. Non-linear means graph and tree. The same way, the same built-in is called primitive. No, user-defined is called non-primitive. So primitive means integer, character, float, and double. Non-primitive means arrays. It may be single dimensional, 2-dimensional, or multi-dimensional. List means linear, non-linear. Linear means stack, queue, and linked list. Non-linear means trees and graphs. And you should know the difference between linear data structure and non-linear data structure. So the linear means array, stack, queue, and graph means there is no linearity. We are using different notation, and while storing the data in the memory also, it is represented differently. So we are in graphs, we are creating vertex and edges, and there will be 1 or 2 vertex, and we can use 1 edges. The same way in graph also there is a root node, child nodes, left and right child, and we have edges and vertex. In tree, there should be one root node. We cannot have cycles, but in case of graph, there can be self-reference cycle. Then we discussed the searching techniques, linear search. How we will define linear search? Some example, and the pseudocode program of linear search using non-recursive. Non-recursive means only iterative statement. For loop we used iterative statement. If it is recursive, within the linear search, we are calling the linear search. So the function calls itself within the same function. So it is recursive. And the next topic is abstract data type. So you should remember the definition of abstract data type. Abstract data type means data along with the operation, data members and member functions, attributes and functions associated with the same data. So data along with function means by default we know classes are classes only. In the user defined data type class only we are using data as well as operation. So in structures only data, no operation. Unions also only data, no operation. Only in classes, data and operation, data and functions. Data is called data members, functions are member functions. We are enforcing data encapsulation, data hiding, and data abstraction. So the classes are having the abstraction. So the best example for abstract data type is classes. So we are creating a number of user-defined classes like we're creating a number of user-defined classes in all the languages like stack, queue, tree, graph, and hash function. This particular abstract data type stack is having its own attributes called top and the size of the stack and the maximum top pointer, size of the array n, and array a of n. And the operations like a push, pop, peek, is empty, is full, these operations are associated with the stack. So attributes along with the function. Queue also, it's having its own attribute like front and rear, size of the queue, maximum size n, and the array of queue of n. And the operations what we are performing with the queue is nq, dq, front, rear, is empty. The same way we are having other data abstract data types and its corresponding operations. Then we discussed the second unit topic, the difference between what is linear search and binary search. How they are progressing. Linear search is linear search is linear, exponential, but binary search is almost constant. Then we come to understand the concept, we taken binary and linear, how the efficiency differs with the number size of the array. If 16 inputs, 32 inputs, all those things are for your understanding purpose. So you need not mug up and you need not write all those things in the answer paper. To understand how the linear and binary is functioning. So number of inputs, if you give 16 inputs and 1000, if n size is 1024, how the efficiency differs and the time required per search, nanoseconds, 16 nanoseconds, 20 nanoseconds, 192 nanoseconds. How the time increases, how the time with respect to the number of inputs. Then we discussed what is linear search, what is the definition, and what is the time complexity, space complexity, algorithmic steps, and pseudocode. Difference between both, and binary search definition, time complexity and space complexity, algorithmic steps, and the pseudocode. And using some example, binary search, how we are performing. We are finding the mid element, comparing the searching element, then we are discarding the first half or second half. The process is repeated. The difference between linear and binary search with respect to the logic, efficiency, data requirement, implementation, time complexity, best and best case scenarios. Pros and cons of binary and linear, computational efficiency. So the topics are very less. So any doubt with respect to unit 1?
Yes, ma'am.
Ma'am, can you please repeat asymptotic notations? What we need to do in it?
The screen is visible. So the asymptotic notation is based on the complex, to measure the complexity only. Complexity means how much time, complexity means we are, the algorithm is efficient or not with respect to the time and space. Because in olden days, the memory is very costly. So they were very stringent about the memory, how much memory the algorithm takes. So the complexity is measured in terms of time and space complexity. Time complexity means if you are using a binary search, how much time we need to run the search. And space complexity means based on the number of steps written in the lines of code written in the program to store the complete program in the memory, how much memory we need to allocate, whether because the program may have 100 lines of code. Each line, depending upon the variables, depending upon the iterations, it may need 10 KB or it may require 20 KB, 30 KB, 40 KB. Say while downloading the apps from the Play Store, where if similar kind of apps are available, say I am looking for some downloader. So if I'm looking for some video downloader, there may be some 10 to 15 downloaders will appear. So if each downloader will have a different rating as well as memory. May some downloader may need 30 MB, some downloader may need only 15 MB, some may require 50 MB. So depending upon my need, so I cannot spend, I cannot give more than 40 MB to an software. So I will go with some software which is providing the downloading, the app which is having 20 MB or 15 MB. So same way, while to store your program in the computer, how much memory, say you are downloading some software and you are installing, there should be enough space in your computer to install the software and run the software. So the time and space is an important role in measuring the efficiency of any particular program. So that is called complexity. And the complexity can be represented in mathematical form by using the asymptotic notations. So the asymptotic notations are classified into, already we discussed in the classroom. Say if you are traveling from one place to another place, some mode of transport is very fast, but we need to spend, say if you are traveling by flight, you need to spend more money. If you are traveling by second class train, you need to spend some money. If you are traveling in third class AC train, the amount will be somewhat less. But if you train, it will take a minimum 6 hours or 7 hours. But the same distance of 1,500 kilometers, the flight will we can travel in within 1 hour or 1.5 hours. So if you are taking the maximum time and maximum memory space for any particular algorithm to measure its efficiency, that is called big O notation. That is a mathematical notation. We are using the big capital O followed by the efficiency for n inputs, whether it is order of n or order of n into n by 2 or order of n square or order of n log n. If you go with the big O notation, we are taking upper bound. So if you are taking the maximum time, then it is called worst case. If your task can be completed within 5 minutes, but by due to some delay and other parameters, errors, if you may need 10 minutes. But if you are allocating 10 minutes for that particular process, that is the worst case. So that particular notation is called big O notation. Big O notation takes the lower bound. The task can be completed within, the program can be executed within 5 minutes. We are taking the minimum required time. So that is called lower bound and best case. That is represented using big omega symbol, the Roman letter. Here we are using the capital O, so we are calling it as big O. And we are using another Roman letter called theta symbol. This symbol is used to, we are taking the lower bound as well as upper bound. We are finding out the average. Not 5 minutes, not 10 minutes. We are taking the average, lower plus upper. We are considering it as 7.5 minutes. So that may be the exact time we can give it one process. So that is called big theta notation. So yeah, as we discussed, if you take different sorting methods, based on, if you take the quick sort, in the best case, it is taking n log n, that is less than compared to the selection sort order of n square. This is logarithmic, it is order of n square. Here it is order of n. For n numbers, here also order of n. The same way, if you take selection sort in best case, it is order of n square. In average case, so it means it is somewhat constant. Best case, average case, and worst case, due to the logic, it is taking the same constant time. But in case of quick sort, if you take, in best case, it is taking n log n, but in the worst case, it is taking exponential, linear, n square. So the notations used to mathematical notations used to represent the time and space complexity is called asymptotic notations. So the meeting will end in another 3 minutes. Any other doubt? Any doubt? For your unit 2, I have shared an PDF file also for sorting and searching. Sorting and searching, we are discussing about two algorithmic concepts, brute force and divide and conquer. Brute force, what is brute force method? And using brute force method, we are sorting, we are performing selection sort and bubble sort. So what is selection sort definition? And what is the algorithmic steps, pseudocode steps? And the same way bubble sort, what is bubble sort, what is the algorithmic steps? And using brute force approach, we are performing linear search. What is linear search? What are the algorithmic steps? And divide and conquer, what is the divide and conquer method? What are the steps we are following? Using divide and conquer method, how we are performing merge sort? What is the pseudocode? And using divide and conquer method, what is we are solving a quick sort? The quick sort method is following using divide and conquer method. What is quick sort? What are the algorithmic steps? Pseudocode. And example. The binary search comes under divide and conquer method. What is binary search? The logic behind working principle of binary search. The pseudocode steps. The algorithmic steps of binary search. The special features of binary search, because we are talking about only two searching methods, linear and binary. Linear is a general method, but binary is more efficient. In the sorting methods, quick sort is more efficient, and searching method binary is more efficient. In binary, it needs order of log n. The same way, quick sort, worst case big O method, order of n log n. So how the binary search is coming under order of n log n, how the binary search works. And sorting, what is the logic behind sorting? What is bubble sort? What is selection sort? Selection sort pseudocode. What is insertion sort? Insertion sort pseudocode. And in each iteration, how the numbers are swapped after comparison. Okay. So the topics mentioned in the second unit: sorting and searching. Sorting using using brute force approach, bubble sort, selection sort, and insertion sort, and linear search. Divide and conquer method, merge sort, quick sort, and binary search. Definitely you will get one question from sorting, one question from searching. Okay, the meeting will end in another 1 minute. Any other doubt? I will take the attendance from the Zoom recordings. If you have any doubt, ask me. As I said, you must write all the question. You have to attend all the question. Mention the question numbers properly and write the heading of the question. If part A, part B is there, you have to answer both the question. There is no internal choice. And 5 more question means you must write 1.5 page. 10 more question means you must write 3 pages. If you are writing half page, 10 lines, I cannot give 10 marks. And whatever heading, subheading is there in the particular question. If they are asking logic, working principle, pseudocode with example, the separate section should be there. Example means example should be there. Pseudocode means pseudocode should be written. Algorithmic steps means algorithmic steps should be mentioned. Example means example should be there. Define means you have to define. Working principle means you have to mention the logic. They are asking any diagram, you have to draw the diagram. Diagram means what the flow chart. So if you know the pseudocode, all the questions from pseudocode, you can write the algorithm, you can explain, you can define, you can convert the pseudocode into program also. You can give sample input output also. Okay, any doubt? Any other doubt?
No, ma'am.
Don't get confused. For every example sorting searching, you take minimum 5 numbers. Don't take 10 numbers and all. Don't get confused. Take minimum value 5 to 6 numbers. Mention the solve the things. And for all the methods, remember the pseudocode. And for all the logic, all the concepts, remember the asymptotic notation, time complexity, order of n or order of n log n, order of n square. I will mark the attendance from the Zoom recording. The meeting will end now. Okay, all the very best. Answer the questions clearly, neatly. Don't strike out and write. Attend all the questions. Distribute the time for all the questions. Use the pages